But how about this? I'll show you. I'll give you a little preview as to why we would do this. Yeah, I'm going to show it to you. Well, it's not the only reason, but that is a reason. What if we needed to integrate something like this? And this is just an example, okay? This is not necessarily like the best thing I could have come up with. But if we were asked to integrate that, that would be some trouble, all right? We would run into some issues trying to integrate this. You come in, you try and be clever, integration by parts, you try all these different things, and it's going to all break down. You're not going to be able to do it easily, all right? You believe me on that? Okay, so what we do instead is this. I split it up, sine squared x times 1 over 1 plus x dx. And didn't we have, we had a 4 on top, didn't we? Yes? Let's just put that 4 back in there just so it'll match up exactly. So we split it up like that, right? And now this right here, I write that as its power series. I convert it to its power series. And then this one right here, I convert it to its power series. Now I haven't shown you how to do that. Stay tuned. The next 2 sections, we'll learn how to turn that into its power series. Okay? Once I have the 2 power series, I multiply the 2 power series together. How do you multiply two power series together? Stay tuned. I'll show you how to do that. So we will multiply these 2 power series together, and guess what you get when you multiply 2 power series together? A new power series. So you get a new power series, and when you look at this power series and you try and integrate it, this is an infinite polynomial, isn't it? So you're just going to integrate this. These are all powers of x. Something to the x plus something to the x, right? And you can integrate term by term, each one of them. And then once you integrate, you get an answer. That answer is a power series, right? And that power series can be converted back to a function. So basically, this is a very powerful way of integrating things that our methods can't do. And yeah, it's great, great stuff. But I'm sure you're ready for another example. All right, let me throw a little wrench in this thing. Same thing. Let's convert this function over. F of x equals 5 over 2 plus 3x. What do you think? Does that look like 1 over 1 minus some junk? Can you make it look like that? What can you do? Take the 5 out? Okay, I'll start with that. 5 comes out, now I've got a 1 on top. Yay, I'm getting there. Okay, now? You want to change the plus to minus minus? I will do that. Next step though, not this one. Let's go for the 1 first. Just a little easier with the algebra if we go for the 1 first. Factor 2 out of the bottom. We factor the 2 out of the bottom, it comes out as a 5 halves, doesn't it? Yeah, you could have changed it, but it would have also changed this to a -1 though. Oh, okay. So then you'd still have to resolve that issue. So I'm taking a 2 out of the bottom, what do I get? 1 plus, what? 3 halves x, right? That's what happens when I pull a 2 out of the bottom. You see it coming straight out? All right. Now, let's go with your minus minus. So this is 5 halves times 1 over 1 minus -3 halves x. Bam, we're there. We're looking for 1 over 1 minus some junk. Here's our junk, right? So this is going to be able to be converted to a power series right now. The power series will be sum n equals 0 to infinity I'm going to decide to leave the 5 halves in there this time instead of bringing it out. I could have brought it out. But then what? Negative 3 halves x to the n. Okay, that's your basic formula. From this directly into the formula is that. But that is not in that power series format. The reason it's not is because I don't have the x by itself. So can we resolve that? Yeah, split them apart. Split them apart. Negative 3 halves to the n times x to the n. And again, you can kind of see now, this piece right here is your c sub n. This piece right here is your x minus a to the n. Do y'all see it? Now, I have not put something on the board that I absolutely have to have, or else this is incorrect. That's right. This is all true so long as, or I'll say if, the absolute value of what is less than 1? Not x. Negative 3 halves x. It's the thing that you actually found here that kind of matched up with the x in the formula, in the general formula. I erased it. It's whatever that little chunk is right there that you wound up putting right here. You need that piece, the absolute value of it, to be less than 1 in order for this to work. But this is not all the way cleaned up. That's not in its prettiest format here. I could rewrite this as 3 halves absolute value of x is less than 1. And then I could flip or multiply by the reciprocal. Really, I need the absolute value of x to be less than 2/3. And that's true. Okay?
Wouldn't you already know it's positive? Couldn't you just skip that last step?
Skip the last step
I mean,
in.
the middle step, not the last step, sorry. Like to take it out and then flip it.
Oh, yeah. I mean, if you want.
Anything skips otherwise.
Yeah, if you want to go from here to here, that's fine. Yeah. I mean, what's really happening right here is that this is turning into absolute value of negative 3 halves times absolute value of x. So I'm splitting it up, taking the absolute value of that, which becomes this. This stays, multiply reciprocal here. All right, pretty good? Questions? Comments? Concerns? Complaints? Convert that to its power series, if possible. The only tool we have in our toolbox right now to change a function to its power series is that 1 over 1 minus whatever that junk is, right? That's the only tool I've given you. Next section, I give you more tools. This one, this is all we got. So can you make it look like that? I can reduce everything by a power of x, right? They all have a common factor of x? Yes? That's okay so long as x isn't 0. You can cancel that out. I think this is the best I'm going to be able to do. See that? And now take the 2 out. How about I take that 2 out on the bottom as a 1/2? You following what I'm doing? Just pop that x squared off. I want this 2 out of here to make it a 1. I factor 2 out the bottom, it comes out right here. I pull the 2 out of that, it becomes a 1. When I pull a 2 out of this, I have to make a 1/2. Do y'all see it? See the piece right here? We don't have to do a minus minus this time. It's right there. Now, what about that 1/2 x squared, though? It's just going to be sitting out front, okay? It's just going to be sitting out front. So here's what I've got. 1/2 x squared times the power series, n equals 0 to infinity of what? Negative? Just 1/2 x to the power n. Is that all right? Now that's not quite the format that we like, right? So let me go a little further. 1/2 x squared sum n equals 0 to infinity of 1/2 to the n x to the n, right? Split that up. So I'd like to know, I mean, seriously, are y'all like following me, or are y'all looking at this like, boy, this looks like really complicated math, and I just stopped paying attention about, well, what time did class start? Like 41 minutes ago. Are y'all, or wait, oh, it's been an hour. Oh. What do y'all feel? Are you following this, or you're like, I'll figure it all out later. Let me just write this down, or let me take a quick little nap. You're okay? A couple of thumbs up? You're okay? All right. Now, we haven't had this happen yet, right? With the x squared out there. Do you think there's anything I can do with that x squared? Can I bring it into the sum, like a constant? Your instinct might tell you no, because it's a variable, right? But the thing is, the thing that's changing in the sums is n. And this x squared doesn't have an n in it. So it can go in. So my next line is going to look kind of strange, but look at this. Whoa. And I'm still not done. I see something else I can do. Did y'all see what else I can do? 1/2 to the first power, 1/2 to the n power can come together as 1/2 to the n plus 1 power. So there you go. We could start plugging in values of n, 0, 1, 2, and start writing this thing out, couldn't we? Now, I am forgetting something, though. I must put this or else this is wrong. This is true, right? If absolute value of what? 1/2 x is less than 1. Which really means that the absolute value of x must be less than 2. So pull your 1/2 out, multiply both sides by 2. Train keeps moving. Term-by-term differentiation of power series. If you have a function, f of x, which is the power series, the general power series, was that one of those I turn my back, they sneak out one of those things? Was that what that just was? Was that? Who snuck?
He just said he had to go.
Oh, okay. So it was one of those wait till he turns ones?
Well, he said he dropped the cloud.
No, I just asking. I felt it. That's what happened. Yeah, just happened to. Well, all right. I don't care, but I mean. Yeah. It was pretty good. It was pretty smooth, but. All right, so let's say that we have a convergent power series. So when I say f of x is defined to be this, I'm assuming that this thing is like defined. It has some interval of convergence, and there it is, right? This is our general power series. This is me plugging in 0, then 1, then 2, then 3, right? That's what it looks like? Then I wonder if it makes any sense to take the derivative of this. Then f prime of x would be, well, it might be easiest if we do it on this piece right here. And just do it one at a time. So what's the derivative of c sub 0? 0, because it's a constant. So derivative of that, it's gone. Now, look at this right here, and tell me what the derivative of that would be. So imagine that that was 3x minus 4, right? If I asked you to take derivative of this, you would just cover up the 3. Derivative of x minus 4 would be 1, right? Then times 3, so the answer would just be 3. So you would just have c sub 1. Make sense? Plus, now check this next one out. Here, cover up the constant because it's just going to come along for the ride. What's the derivative of that little polynomial there? 2 drops out. It's that to the first power times the derivative of what's inside. Derivative of what's inside is just 1. So all you're going to have is the 2 times this, 2 times c sub 2, and then you still have an x minus a to the first power, don't you? And you kind of see the pattern now? What would this next one be? 3 would come out. 3 c sub 3, x minus a squared. Let's predict the next one. 4 c sub 4, x minus a to the third, and so on and so forth, right? So it looks like the derivative is pretty well defined. Can you give me this in sigma notation? In other words, if I ask you right now, can you generate this right here using that notation? It requires a little bit of a leap here, not much, but a little leap. Let's take a note of these powers. The powers are what, 1 here on that one? The coefficient here is 1, so look at just the numbers. 1, 2, 3, 4, right? Look. C sub 1, 2, 3. So go ahead, what? I'll write it down. You just give it to me. Go. N times C sub n? X minus a to the n minus 1. Where do you want me to start n at? N at 1?
Oh, yeah.
Okay. Does everyone agree with this? If I start at n as 1, then I'm going to have n, which is going to be our 1, c sub n, which would be like c sub 1, and then x minus a to 1. The power is always 1 less than the number out here, right? And notice that this formula does work. It does give me c sub 1. Because if I plug in 1, 1 minus 1 is 0. All of this to the 0 is going to be 1. So you would just get 1 times c sub 1, which would be c sub 1. So do y'all agree that formula works? Question? No? Yeah? Are you disagreeing, or you have?
I'm just like trying to check like the next one.
You want to check the next one? Okay. How about? Let's write them out. Okay. Let's plug in 1. 1 times c sub 1, x minus a to the 1 minus 1. 1 minus 1 is 0. This to the 0 is 1 times c sub 1, right? So that first term is c sub 1. Try the next one. Plug in